This is the Current Meter Project Part 3. You should have previously watched Current Meter Project Parts 1 and 2 on my YouTube channel as well. In this part, we're going to take the schematic and build the layout on a breadboard. So here's my setup with my power supply. You can see I've got it reading almost exactly 5 volts. We can try to just get a little bit better, but 4.989, it's about as close as we're going to get. 4.997. That's right there to 5 volts. So now I'm going to take this 5 volt lead, I'm going to connect it from the power supply to my series of resistors. This is my first branch. Again, I have a 4.7K, a 150, and a 22 ohm resistor. Current will flow through the resistors, then along this red wire to the meter. It's connected to the back of the meter here, and then returning from the meter back to my power supply. So we'll connect this up and see what happens, and there you go. Full scale deflection at 1 milliamp right there. For branch number 2, I have 3 resistors also in series, a 330 ohm, a 220 ohm, and a 5.6 ohm resistor. And so that adds up to the total of 555.6 ohms. Now, instead of having the analog meter connected directly to the power supply, this time I'm going to connect the power supply return the negative to this negative rail on the breadboard, and I'm going to have my resistor, the 5.6 ohm resistor, plugged into that negative rail also. But I'm going to use this green jumper wire as a switch, so current will flow from this wire to the positive rail on this breadboard, which is connected to this first resistor that will send the current through the meter. It's also going to be connected to the second branch, the shunt series of resistors, as soon as I plug this green wire into the positive rail. But I also need to connect my analog meter to the return path. So I'm going to plug in a jumper wire there and connect my negative lead to the other side of that analog meter. Then as soon as I plug in the power, it should, again, that's 1 milliamp of current through the meter only. If I connect this green wire on the breadboard to the negative supply, completing that circuit, notice the meter did change just slightly, barely. Actually, you can hardly even detect that, but that's sending 9 milliamps of current through that second branch. Alright, and here is the third shunt branch. This branch is 2 100 ohm resistors in parallel with each other. This time I've connected the return path through this green jumper wire back to the negative rail on the breadboard. And right now the meter's reading nothing. I'm going to disconnect the second shunt circuit. Now I've only got the analog meter. Currently that's reading 1 milliamp. Now if I connect this shunt branch to the positive rail, the meter stays at full scale. Finally, I have my last shunt current, shunt branch. It's got 400 ohm resistors in parallel. I'm using the precision 5-band resistors. Right now I have just the analog current meter connected up to my power supply, and it's reading 1 milliamp. And then as soon as I attach this red jumper wire, notice I have a return path to the meter, to the power supply through this green jumper wire here. But as soon as I attach this red jumper wire to the positive, that meter should stay at full scale, and it does. So I have a current meter capable of measuring any current from 0 up to 200 milliamps. But at any time, only 1 milliamp of current will flow through the meter. The other currents will be shunted through these series parallel networks. So that's one way to design and build this kind of current meter.